Hi, this is Maureen Schickel. In this tutorial, we will talk about how you can prepare cardiac and vascular models for 3D printing with the PolyJet Digital Anatomy materials using Materialise 3matic. To start, let's go over a few file preparation considerations for cardiac and vascular models. First, be sure to include openings in the model to enable support removal from internal cavities. Next, create a separate STL file for each digital anatomy material being used in the model and avoid or remove intersections between each of these STL files. Finally, for the digital anatomy materials, an additional STL file is needed to represent the internal cavity of the cardiac or vascular model. Instead of using the standard support material, this internal cavity STL file will be assigned the GelMatrix material, which helps ensure that the support material can be removed from internal cavities. In this tutorial, we will focus on the last point, creating a STL file to represent the internal cavity of the model for the GelMatrix material assignment. Here, I have an aortic root model example. I have already completed the segmentation of the blood pool and calcifications. In addition, I hollowed the blood pool and trimmed it to create a vessel wall model, and finally subtracted the calcification to remove intersections between the vessel wall and calcification models. Now we can take a look at the process of creating an STL file for the internal cavity. The manufacturer recommends ending the internal cavity STL file 1 millimeter before the opening of the model so that the standard support material enters a short distance into the internal cavity of the model. To create the internal cavity model, we will trim the blood pool model so that it is 1 millimeter inside the vessel wall model. To perform these cuts, we first need to define datum planes at the vessel openings. We will use the normal and origin method and select the triangle normal on the cut face of the vessel wall opening. Once we have defined one datum plane, we can go ahead and select additional as needed. Looking at the results, you'll see that some of these datum planes intersect with other portions of the blood pool model that we may not need to cut. So we will need to adjust the size of these datum planes. To do so, select each datum plane and go to the Properties tab. You can adjust the dimensions using the delta X and delta Y parameters. Next, we will move each datum plane so that it is 1 millimeter inside the vessel wall opening. To do so, we will use the interactive translate tool. We'll select one datum plane at a time. The coordinate system will be set to object coordinate system, and we will turn on the enable snapping and translation step to 1 millimeter. Now we can grab the arrowhead to translate each datum plane 1 millimeter towards the inside of the vessel wall opening. Finally, we need to convert the datum planes to surface files because the analytical primitive datum planes that we are working with right now are treated as infinite planes when cutting. So we will select each of the datum planes and convert to parts. Hiding the analytical datum planes, we can see we have our final parts, and they should not intersect with our blood pool model. To perform the cutting, we will use the cut tool, selecting the blood pool and one of the datum plane surfaces at a time. This will create two new parts. We'll throw out the small one and continue cutting the larger of the blood pool parts with another datum plane surface. We should now have our final model of the internal cavity with the 1 millimeter insets from the vessel wall model. A final step would be to ensure that this new internal cavity does not have any intersections with any of the other STL files that we are planning to print. In this case, we should do a final Boolean subtraction between the internal cavity model and the calcifications, since this wasn't accounted for in the original blood pool model. Finally, we can take the resulting models, the calcifications, vessel wall subtracted, and the internal cavity subtracted models, and export them as STL files to be used in the build preparation step. In summary, we have demonstrated how an internal cavity STL file can be generated using Materialise 3-matic so that cardiac or vascular models can be 3D printed using the PolyJet Digital Anatomy materials. Thanks for listening.